My name is Paulson Cunningham, and this is my lab report for Physics 2212 Lab 1 Charge Take. The purpose of this experiment is to experimentally determine the ratio of deficit of excess electrons on U-tapes, and in doing so showcase my knowledge of the physics principles at play. The principles are that of charge on everyday objects, and how every object is subject to force, which can be written as kqqq over r squared, and then balancing that with gravitational force, which again every object experiences, and that is gmm over r squared, or just doing here on Earth would be m times g. And the last principle is polarization, and that's where charges separate in neutral objects in an electric field. So just by introducing an object to an electric field, you're going to get polarization. My expectations going into this experiment were that the U-tapes would repel one another as they have like charge. The U-tape will be attracted to neutral objects due to the polarization, and U-tape will repel the charged one. My assumptions I made in this experiment were that charge on the tape can be approximated using without charges rather than the charge spread out throughout the whole tape. Electrons are evenly dispersed and it exists solely on the underside of the tape, and both U-tapes have equal magnitudes of charge. My experiment consisted of cutting, measuring, and weighing through pieces of tape, making two U-tapes and keeping them electrically insulated by ripping off pieces of tape, suspending one U-tape horizontally. I laid it on two Band-Aid boxes to keep it above the desk, and then to lower another U-tape on top of the first to record the distance which the tape begins to hover, and then perform the calculations on the following slide to determine the amount of charge on the U-tape. Here's a little proof that like charges repel and that the two U-tapes will repel one another. And here's me measuring my U-tape. Here is the math. I started off by determining the force of gravity on the tape. So we have the mass times the average acceleration of gravity on Earth to get our force. Then I equated the force of gravity to the Coulombic force. Plugging in the numbers and doing some math, I got 7.152 times 10 to the 10th electrons. And then to determine the ratio of atoms that actually can put up an excess electron, I found the area of the tape I used and found the average area of an electron and divided the two to get 6 times 10 to the 17th. From there, I divided the two. So the inverse of this, it got flipped here, but yields 1.2 times 10 to the negative 7th, or 0.000012% of atoms gained an excess electron on the U-tape. Here's my code that I ran. You can see the two approximated point charges, which would be the tape. There's the orange arrows showcase the electric field from each tape, and you can see this blue arrow here is the mass due to, or the force due to gravity. And then you can see roughly how many electrons on each piece of tape, and this is the and here's a link to my code to run through that. Comparison between my experiment and my code. Obviously, I'm very imprecise and clumsy, and in touching the tapes, I stole some of the electrons off the tapes, making my magnitude in the experiment a little bit lower than that for my code. And I use different lengths of tape when doing the experiment, which would mean that there's unequal amounts of electrons on each, but we're going to assume that there's equal charge on both pieces of tape and that the charges congregate in one point for both experiments. And in my code, there's nothing to interfere with the charge on the tape. Why is it important to handle the charged tape as little as possible? Well, because in touching the tape, the excess electrons repel one another, and the net charge will diminish on the tape as electrons leave the tape in favor of the neutral hands or other objects such as desk. If electrons and protons switch charges, then my experiment would pretty much go the exact same, except now the positive charges are going to be the ones that are leaving the tape. The two tapes are still going to repel one another, and it will still be the same separation. Well, really, the only thing that would change to my experiment would be that the tape would now be attracted to the charged member element. Thank you for watching. Take it easy.